This is demonstration number 14 from the aviation textbook, Advanced Airmanship, Book 1, Precision Flying. This demonstration examines a common precision pitch transition that combines the basic pitch transition rules illustrated in demonstrations 9 through 12. This transition shows the precise capture of an altitude from a descent, followed by a deceleration to a slower airspeed. The data plot view will be shown first, followed by the same transition shown in the flight deck view. The initial descent is at a pitch attitude of 0 and idle thrust. The plotting speed will now be reduced to 0.1 times the normal value to illustrate the details. At a lead of 24 feet, we will rotate to the 0 rate pitch attitude of 2.6 degrees to capture 7,000 feet while maintaining the thrust at idle. As the pitch attitude is increased, the vertical speed is decreased. Even after the final pitch attitude is established, the vertical speed continues to decrease. The vertical speed will reach 0 feet per minute as the altitude reaches the target value of 7,000 feet. Now that the altitude is captured, as the airspeed decreases, an increase in pitch attitude is required, coordinating pitch with airspeed in order to maintain a constant altitude. As we approach the target speed of 210 knots, the EPR will be set to 1.05, which will maintain the airspeed constant. Using an experimentally determined altitude lead, rotate to the 0 rate pitch attitude. The altitude lead depends on the rate of climb, pitch rate, and required pitch attitude change. The 0 rate attitude achieves 0 rate of descent at the airspeed that exists at the completion of the attitude change. After altitude capture, altitude will begin to decrease with decreasing airspeed if the pitch attitude is not increased. Therefore, after reaching the desired altitude, coordinate an increase in pitch attitude with the airspeed reduction to prevent an altitude change. Slightly before reaching the desired final airspeed, increase power to the setting that will maintain that speed. Time the power increase so that both the desired power and airspeed are reached together. Notice that the final power setting was established after the final airspeed was reached. In this case, the final power setting was greater than the descent power setting. This method provided the most timely airspeed reduction. However, if the final power setting is less than the descent power setting, then the most rapid reduction in airspeed will be accomplished by setting the final power value at the beginning of the altitude capture pitch change. We will now repeat the demonstration in the flight deck view. Notice that the change in pitch to 2.6 degrees has been accomplished, and the vertical speed reaches 0 feet per minute at 7,000 feet. Now, as the airspeed decreases, an increase in pitch attitude is required in order to maintain the altitude, coordinating pitch attitude changes with airspeed changes. And as we approach a target airspeed of 210 knots, the power setting will be increased to the value necessary to maintain that speed. The altitude remains at 7,000 feet and the airspeed at 210 knots.